Hello and welcome to another Common Core Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit 1, Lesson 4, Basic Exponent Properties. Now we've already worked with exponents a little bit, but it's important that you have a nice solid foundation in how exponents work, the kind of rules that they live by, and how to view them. Alright, let's jump right into the first exercise to get some sense for how we use exponents and what they're there for. Okay, the basic exponent idea. You've been seeing exponents for a long time, and what most people feel comfortable with is that positive integer exponents. Positive integer exponents, make sure you understand that. Those are things like, x to the fifth or 3 to the seventh, right? Positive integer exponents are simply a method of showing repeated multiplication by the same number, the base. In this case, the base is x. In this case, the base is 3. So we're not talking about negative exponents, all right, although we will eventually. We're not talking about fractional exponents, and we'll certainly get into those this year. We're talking about positive integer exponents, just meaning repeatedly multiplying. Okay? So let's take a look at exercise number 1. The following 4 steps are given to find the product of the monomials. A monomial is an expression that is a single term expression. Mono meaning 1. Okay, and we're going to find the product of negative 2x to the fifth times 4x squared. For steps 1 through 3, write the real number property that justifies each manipulation. Finally, letter B says, explain why the final exponent on the variable x is a 7. Okay? Well, what's the first thing I do? I've got this product, and I rewrite it so that I'm then doing the product of x to the fifth times 4 first. Well, that's what's known as the associative property. The associative property says, hey, look, if I've got a bunch of multiplication, we can decide which two things we want to multiply first. Then all of a sudden in line 2, I say, hey, x to the fifth times 4 is the same as 4 times x to the fifth. Well, that's the commutative property of multiplication. Finally, I'm going to decide, I think I'll actually multiply these two numbers and these two numbers. That's again associative. So a bunch of associative and commutative properties basically just say to me, look, do whatever you want. If you've got a bunch of multiplication, do it in whatever order you decide to. Well, the final question was, why is it that the final exponent is to the seventh? Well, that really just comes from what exponents are, right? X to the fifth, written as what's known as an extended product, is 5 x's multiplying each other. X to the second is 2 x's multiplying each other. So ultimately, we've got x to the seventh because there are 7 x's multiplying each other. It's real simple. But of course, a number of people might look at x to the fifth times x to the second and think, x to the 10th, 5 times 2. But that kind of ignores what exponents really mean, which is repeatedly multiplying, in this case, by a base of x. Okay, I'm going to clear out the text, so pause the video if you need to. Okay, here we go. Exercise 2. Find the product of each of the following monomials. Now again, we could rearrange these things and walk through each step, but ultimately, what do? We take the coefficients, 5 times 3, and we multiply them. We get 15. Then we take x squared times x to the sixth, and we get x to the eighth, because remember, there's really 8 x's multiplying each other. Why don't you pause the video and do letters B, C, and D. Try to do as many as you can without a calculator, including letter C, where you have a fraction involved. All right, let's go through them. Well, negative 2 times negative 6 is a positive 12. X to the first times x to the fourth means we've got 5 x's multiplying each other. Let's do a little fraction multiplication. Remember, multiplying by 3/2 is the same as multiplying by 3 and dividing by 2. So if I first do the division by 2, then I can do 3 times 3 and get 9. X to the 4th times x to the 10th will be x to the 14th. All right, and this last one's a bit confusing. But remember, ultimately, if I just ignore the 4x cubed, what it means to square something is to multiply it by itself, right? So that's really 4x cubed times 4x cubed, in which case we have 4 times 4, which is 16, and x to the 3rd times x to the 3rd will be x to the 6th. Notice effectively what I did was I squared both the 4 and the x cubed. Now, we can have problems like in exercise 3 where more than one variable is involved. That's fine as long as it's all just monomial multiplication. No binomials, no more complicated expressions. And the reason that we can do this is, again, because of the commutative and associative properties of multiplication. In other words, I can say, look, I'm going to do 4 times 5 and get 20. Then I'm going to do x cubed times x to the 1st and get x to the 4th. Then I can do y squared times y to the 5th and get y to the 7th. And again, all of that is associative and commutative properties of multiplication, which basically just gives me permission to multiply in any order I'd like. Why don't you go ahead and do letters B and C? Okay, let's go through them. 3 letter B, I'll have -2 times -4. That'll be a +8. X to the 7th times x to the 2nd will be x to the 9th. Y to the 3rd times y to the 6th will also be y to the 9th. Let me rewrite that again, just so that you're absolutely certain that that's a y to the 9th and not a y to the 4th or something like that. Letter C, a little bit complicated because of the fractions. Remember, when multiplying fractions, you multiply their numerators, you multiply their denominators, none of that common denominator monkeying around. X to the 1st times x to the 2nd will be x to the 3rd. Y to the 1st times y to the 5th will be y to the 6th. And again, not so much looking like a 4. There it is. Okay, pause the video now. All right, I'm going to clear out the text. And then we're going to go on and talk a little bit about factoring. All right, factoring is what I loosely call unmultiplying. Whenever we factor something, all we're doing is writing a term or an expression as an equivalent product. Many times we have to use concepts about exponents to help us factor. So exercise 4 says fill in the missing blank in each of the following equations involving a product such that the equation is an identity. All right. In other words, right, I mean, I could have anything in here. 6x to the 5th equals 2x squared times Fred if I wanted to. It just won't be an identity. I have to say, look, 6x to the 5th is always equal to 2x squared times what? Always equal. Well, in order to get the 6, I'd have to multiply the 2 by a 3. Right? 2 times 3 is 6. In order to get an x to the 5th, I'd have to have an x to the 2nd times an x to the 3rd. So there it is. Just filled it in. I just factored 6x to the 5th. All right. So what I'd like you to do is attempt letter B and letter C on your own. All right, let's go through it. Well, we think to ourselves, what do I have to multiply 4 by to get 12? And that would be 3. What would I have to multiply x to the 3rd by to get x to the 8th? And that would be x to the 5th. Simple enough. Take a look at this last one. I'm thinking, what do I have to multiply -2 by to get +20? And that would be -10. What would I have to multiply x by to get x squared? That would be x. What would I multiply y cubed by to get y to the 4th? And that'd be y. All right. Factoring is very, very important. We're going to see it a little bit more this lesson, and then obviously it's going to be a big, big part of this course. Okay, I'm going to delete the text, so pause the video now if you need to. All right, here it goes. Now, So far, what we've confined ourselves to, limited ourselves to, is multiplying monomials by monomials and then sort of unmultiplying when we do the factoring. But there's no reason we can't use the distributive property to take a monomial and multiply it by a binomial, a trinomial, etc. Of course, the key in all of this, right, with the distributive property is saying, well, I'm going to take 2x and I'm going to multiply it by 5x, and then I'm going to add on 2x times 3. Many students won't write out this initial line, and that's okay, but you need to be careful, right? I'll get 2 times 5, and I'll get 10, and then I'll get x times x, and I'll get x squared. Here, the only thing I can really do is choose to multiply the 2 and the 3, giving me 6, and then, as I say, the x just kind of comes along for the ride. So 10x squared plus 6x. Let's do one more of them together, and again, I'm going to write out in all of its glory. I'm going to have that 5x cubed times 2x squared. And then I'm going to have a 5x cubed times negative 3x. We'll talk about that for a moment, in a moment. Then I'll have 5x cubed times positive 6. Now, some of you will choose to have a subtraction there and then a positive 3x there. Some will choose to have an addition and a negative 3x there. Whichever way is easier for you to think about, you should go with, and try to be consistent. Anyway, let's get the final answer. 5 times 2 is obviously 10. X cubed times x squared would be x to the 5th. Now I have 5 times negative 3, which is negative 15. See, now I got that subtraction back. X to the 3rd times x to the 1st will be x to the 4th. Then I'll have 5 times 6, which is positive 30. And then that x cubed comes along for the ride. All right. So what I'd like you to do is pause the video now and try letters C, D, and E on your own. All right, let's go through them. If you haven't written out these initial steps, but you find that you're getting the answers right, oh my goodness, I don't think I have enough room. Sorry about that, folks. We'll just have to bring it down to another line. But if you're finding that you don't have to write this first line out, you're getting the answers correct, that's great. Eventually, I'll stop writing it as well. Negative 7x to the 4th plus 14x to the 3rd minus 21x squared. Let's take a look at the next one. Ooh, our monomial is a little more complicated, but we'll give it a shot anyway. Again, no big deal here. We're just going to choose to do the x times the x squared. That's going to give us the x cubed. And the y squared has to kind of hang out. Here, we've got x. It's not really multiplying anything over here that also has an x in it, but we'll have a y times negative y squared. That's going to be negative. Then y squared times y squared would be y to the 4th. Oh my goodness, look at this one. Whew! This is going to take me more time to write out than it will to actually do the problem. That's why many of you will probably choose not to write out the initial line eventually, because it does, if you will, slow you down a little bit. And apparently it makes my pen stop working. Ooh, there we go. All right, let's do it. 3 times 2 is 6. X squared times x squared is x to the 4th. Y to the 4th times y to the 1st is y to the 5th. Ooh, let's do it. Plus 3 times 1 is 3. I say 1, even though there's not a 1 written there. You can always write a 1 there. X squared times x is x cubed. Y to the 4th times y squared will be y to the 6th. 3 times negative 4, negative 12. X squared times, just x squared. Y to the 4th times y cubed, y to the 7th. There we go. All right. So pause the video now and write down anything you need to. Here we go. Let's get some practice factoring again. Now what we're going to do is we're going to kind of go in the opposite order. We're going to factor. And just like we did before, what I'm doing is I'm just asking you to fill in the missing portion of each product so that an equation is an identity. Let's do letter A together. Right, so here I've got 8x squared minus 12x, and I want that to be equivalently written as 4x times something. Well, let's do exactly what we did before. We're reversing the distributive property, so I have to think, what do I multiply 4 by to get 8? And that would be 2. And then what do I have to multiply x by to get x squared? And that'll be x. Now this negative, that's just got to come along here. Then I think, what do I multiply 4 by to get 12? And that'll be 3. But I don't want any x here, because if I have an x here, then x times x is x squared, but I only have an x to the first. So that's it. Now, what I'd like to do here is I'd like to do one more with you, okay, and then have you work on them yourself. So again, 7x to the fourth, 7x squared. Well, the 7's already there. What I need is I need an x squared, so x squared times x squared is x to the fourth. That minus is going to kind of come along for the ride. Then think, well, what do I have to multiply 7 by to get 21? That's going to be a 3. What do I have to multiply x squared to get x cubed? That's going to be an x to the first. Again, that next negative comes along. What do I have to multiply 7 by to get 28? That would be a 4. Here I have an x squared, here I have an x squared, so no x's. That's it. All right. Well, why don't you pause the video now and try to do letters C and D. Okay, let's do it. Not the biggest blanks here. If we need to, we'll take a little more space up top. But what do I have to multiply 5 by to get 10? Well, that's going to be 2. What do I have to multiply x by to get x cubed? That's going to be x squared. Y squared, already taken care of. Minus 5 times 4 is 20. X squared, I got to have an x here. X times x is x squared. Y cubed here, y squared there. I'm going to need a y, right? Y times y squared is y cubed. Finally, 5 times 7 is going to get me 35. The x to the first is there. Y to the fifth, y to the second gives me y to the third. All right, let's try this last one. Whoa, what? Well, nothing says that we can't factor a more complex expression out, x minus 2. Well, think about that. That x minus 2 is multiplying a 4x squared, and this x minus 2 is multiplying a negative 9. So that's it. All right. So pause the video now and write down anything you need to, and then we're going to clear it out and finish up. Okay, here we go. So in today's lesson, what we did is we just reviewed the basic way that positive integer exponents work. We're going to see a lot of different integers this year: positive, negative, zero, fractional. About the only type of exponent we're not going to see this year are irrational exponents. And even that they are going to be in there. They're just going to be in there in a subtle way. So we'll get more work with them in future lessons. For now, I'd like to thank you for joining me for another Common Core Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.